All right, we're going to move up here to chapter 5. We're going to kind of hopscotch around a little bit here to cover some of the topics that you're going to see in your ITBS test here in March. So we're going to start here. We're moving up to chapter 5, 5.1, rates and functions. Okay. Our essential question is, what is a function and how can we represent it with a graph? Okay. What is a function? Technically, it's a relationship that assigns exactly one output value for each input value. The operation performed on the input is given by the function rule. Okay? It's an equation, and that's what a function rule is. It's an equation. It's an equation like distance equals rate times time, where you might throw in, let's say you're moving at a rate of 10 miles per hour, and you want to know how far can I go in an hour? How far can I go in 2 hours? How far can I go in 3 hours? Okay? So the rule, distance equals rate times time, that's your equation, that's your rule, okay? And the values that you're plugging in, okay, into the input may be the times, okay? And then, when you plug in, if you're moving 10 miles an hour, in 1 hour, you're going to go 10 miles, okay? So you plugged in one input time and you got exactly one output, okay? If you're moving at 10 miles an hour in 1 hour, you're only going to go 10 miles, okay? Couple vocab words here, domain, and you're going to see this a lot throughout algebra. The domain is the x values, okay, the x values that you're putting in. The range is the y values. It's the answer you get out. In the example I just gave you, the time, 1 hour, 2 hour, 3 hours, those could be your x values, and the answers you get from that, the distance, could be your y values, okay? And we'll get into a lot more of those kind of particulars there, but just realize that the domain is the numbers you're plugging in, and the range is the answers you're getting from the equation when you do that. Okay? What is a function rule? We're going to start looking at it in an organized table, okay, with inputs, outputs, along with the rule, like this, okay? So our rule is the equation. We're going to start out this way. A student movie ticket costs $3. Make a function table that shows the total cost for 1, 2, 3, and 4 tickets. Then identify the domain and range. So here's your number of tickets. You're going to buy 1, 2, 3, or 4. Each ticket is $3. So if you want to know the total cost, one ticket is 1 times 3. 2 would be 2 times 3, 3 times 3, and 4 times 3. So this is the cost for each of these number of tickets. Okay? So you are plugging in the number of tickets. That's your domain. And the total value, what it was going to cost you, that's your range. That's what you got out of that. Okay? So we were taking 3 times x. You could think of the number of tickets as x. And y would be your domain. Okay? Boom, boom. So 3x would equal y. 3 times the number of tickets gives you the total cost. Okay? That's what it looks like algebraically, or one way it could look. All right? And again, we're going to keep getting into this as we go. Real world example. A botanist discovers that a certain species of bamboo grows 4 inches each hour. Write an equation using 2 variables to represent the situation. B, find the growth after 6 hours, and C, graph it. If we say G is the growth in inches, and H is the hours of the growth, then the growth is going to equal 4 times the number of hours, because it says it grows 4 inches every hour. So the growth, how high it is, will equal 4 times H, the number of hours. How far after 6 hours, or how tall is it after 6 hours? 4 times 6 is 24 inches high. Okay? Now, if we want to graph this, it's going to look like this. Okay? Here's our x and our y. Our x, in this case, is going to be the number of hours. And our y here is going to be its height. How tall did it grow? Okay? So, of course, at 0, it's nothing. After an hour, it's 4 inches, and I went up every 2 here. So it's 4 inches after an hour. After 2 hours, it's 8 inches. After 3 hours, it's 12 inches. Because 3 times 4 is 12. Okay, so and you can see, I can draw a line through here, a straight line. This is called a linear equation, because the graph gives me a straight line. Okay, and you can keep going. 4 inches, 16, 5 inches, 20, everything's going to line up on this line right here. Okay? So without getting real deep in everything right here, that's basically what we're looking at. Make a little table, plug in some values for your x, or for h in this case, and see what you get out here for y. Okay? Let's take a look at another example. This is from the book on page 250, example 4. Okay, you got a race car that travels 231 miles per hour. All right. First question is write an equation relating m miles that the car can travel in h hours. Well, the thing to remember here is the equation distance equals rate times time. Okay. Now this gets used a lot. All right. So you've seen it in science. You'll see it in physics. You'll see it in all kinds of things. Okay. So miles is our distance, right? You measure, in this case here, we're going to measure distance in miles. So I'm going to put an m for my distance there. And then my rate, looks like my pen's dying. My rate is given at 231 miles per hour. So m equals 231 times h hours, t hours. So I put my m in for miles, distance. H is hours, that's time. And the rate that we're traveling is 231 miles per hour. They told me that right there. Okay, so there's my equation right there. Now we can make a table here. And we can have how many hours we're traveling. 1, 2, you make it as big as you want. How many miles have we gone? That's going to be 231 times 1 hour. 231 in 2 hours. So that's 462 and so on. Okay. How far have we gone in 3 hours? 231 times 3, and that's going to be 693 miles. Okay, so a function is an equation. Function rule is an equation. The numbers you plug in for x make up your domain. The range is the y values, the answers you get from it. Okay, these would be our x's. This would be our domain. This is our y values. This is what we get for our range. We'll talk a lot more about this right now. I knew a lot of this stuff's going to be kind of new. We'll try to keep it simple right now and work our understanding of it as we go. Okay, so we'll get after this tomorrow. We'll see you in class. Have a good one.